Oh hey, didn't see you there. But welcome to our down and dirty pump refresher.
So today we're going to review a few pump topics, but first we are going to teach you the hand method.
Sometimes you got to get the 2.5 to do some adulting on the fire ground. Advanced fire conditions. Defensive operations. Unknown location.
Or extent.
Large undivided area. Tons of water. Standpipes and sprinklers.
To understand our PDP, our pump discharge pressure, we need to understand a few things. Nozzle pressure, which is the PSI required to flow water at the end of the hand line. Next, friction loss, which we'll come back to with the hand method. Then we have appliance pressure, which we add 10 or 15 for aerial master streams. Then we have elevation, plus or minus depending if we're subgrade or above grade when your pipeman is in an elevated position. So in summary, PDP equals nozzle pressure plus friction loss plus appliance plus or minus elevation.
Just start at the nozzle and work backwards.
To find our friction loss, we got to use the hand method. But first, we need to know our GPMs that we're flowing on the 1-inch plate pipe. Hey Stewie! What GPMs do you got?
200 GPMs on the 1-inch plate pipe.
So Stewie needs 200 GPMs. So we're gonna start here at the base of my hand at the hundredths. So we can come here to 200 GPMs and we'll go straight up to 4 as our multiplier, which gives us 8. So we know we'll have 8 PSI friction loss per 100 feet of hose. So Stewie's at the end of a 200-foot blitz line. So we know we have to double our friction loss. So we started with 8 at 100 feet. So now we know we have 16 PSI. And we're gonna add 50 for our hand line, giving us a total of 66 PSI for our PDP.
Driver Dan, what GPMs do you need on the TFT Metro 2? 250 GPMs! My partner on the hand line needs 250 GPMs. What we're gonna do is multiply cross. 4 times 3 or 2 times 6. Either way, we're gonna get 12 PSI friction loss for every 100 feet of 2.5 hose line. And with that total of 12 PSI for friction loss, we add that to our 50 PSI nozzle pressure on the fog nozzle for a total of 74 PSI. We'll call it 75 PSI.
Let's refresh our hydrant capacity, which helps us determine how much water we can flow off of a given hydrant.
To find hydrant capacity, we're going to use the first digit method. In doing that, we need to find the difference between the static and residual pressure. For the first digit method, we're going to have our static and residual pressures. We're going to find the difference of those, take the first digit of our static, multiply by 1, 2, and 3 to get our values. If our value is greater than or equal to our difference, that'll be how many like amounts we can flow. For example, the first digit from our static times 1, if that value is greater than or equal to our difference, we can flow 3 like amounts.
To calculate our static pressure, first charge the hydrant and open the PIV. Take note of the static pressure before opening any lines flowing water or the recirc valve. So for example, if we have a static pressure of our hydrant of 90 and our residual is 75, we have a difference of 15. So if we take the first digit of our static pressure, which is 9, and we multiply it by 1, 2, and 3, we get 9, 18, and 27. So we see that 18 is greater than or equal to 15. Because 18 is greater than or equal to 15, we can flow 2 like amounts. So if we're flowing 500 GPMs, we can safely provide an additional 1,000 GPMs, giving us a total of 1,500 GPMs.
Now that we reviewed friction loss and hydrant capacity, let's briefly talk about standpipes and sprinkler systems. Let's not forget for our standpipe systems, we're charging our truck at 100 PSI plus 5 PSI for every floor minus the ground floor. And let's not forget to charge our FDC sprinkler systems to 150 PSI.
Thanks for watching. That was your down and dirty pump refresher.
And we'll see you on the Boomer.